Thank you. It's good to be here. My first time on LaraCon, and they let me talk for the first time, so this is awesome. Can everybody hear me okay in the back? Awesome, thank you. If by any chance you hear me lower my voice, or if you hear me start mumbling, please tell me so I can improve right then and there. So, hello everyone, and welcome to the premiere of this talk. You might have heard that this talk was given before, but this is a completely different beast. So, for starters, introduction, who am I? My name is Vranac Srđan. I am from Novi Sad in Serbia. I am a consultant who has been doing this for 20 years or so. I'm a proud father of two girls. One is 9 and the other one is 2 months old. If I'm not in front of the screen or working, I'm spending time with my family, or if not that, then I'm somewhere on a trail with my dogs just getting lost and having fun. As we will be talking about one aspect of security, the original title of the talk was actually a cover. The real title is C-Tech Astronomy, which is actually very fitting because it is an anagram of too many secrets, right? I picked this up from an old movie called Sneakers, and in real life, this ended on the pages of National Reconnaissance Organization, which is basically a group that manages American spy satellites. And kind of perfectly describes this talk, because as developers in our daily life, we deal with too many secrets as credentials to databases, to third-party services, to whatever. Like, that's too much. This talk basically came to be when I was leaving a project for a large company that was making a lot of money, and by pure accident, after 3 months of termination, I entered the wrong credentials and I got into the system. And I go like, I did this by accident. Why are my credentials not revoked? I contact them. They say, sure, we're going to fix it. I try it a month later, still not fixed. 6 months later, after I don't know how many emails, I told them, like, final notice, you have been warned. If anything happens, not my problem anymore. Then I thought, like, this is something that is worth exploring, and I started digging into this. And my first initial contact was basically with C-suite people or VPs or team leads. And you know, when I talked about them, it was either they're loving it, that somebody is actually talking about this, or they were mildly very interested because they were not thinking about this, and this is a problem. On the other hand, when I talked to my fellow developers, I got a lukewarm reaction, which meant I was onto something, right? So this is kind of the gist of it, and this could have been a very, very short talk, but let's manage expectations. If you are still searching for the answer to the difference between a junior and senior developer, this talk is not for you, right? If you're expecting some kind of DevOps hardcore security talk, you'll be disappointed right now, let me tell you. If you're expecting this to be some kind of a rant, you will definitely be disappointed. What I'm going to talk to you today is about securities and secrets management while trying to look at them from a business point of view, right? This talk is aimed at developers who want to become engineers. I will touch on a few subjects that I find that we as industry are lacking in, and that is primarily talking to the business and about business, because apparently it still comes with the stigma of being very unclean, and I think this is very bad. Hopefully, by the end of this talk, you will have some new insights, knowledge, and actionable advice how to approach this subject and others. Please make note that every time that I say you, I mean we, because I'm out there with you making these mistakes and trying to be better. So, in order to survive this talk and hopefully fully appreciate it, you will need to take off your developer's hat and put on your business hat, right? Because some of you might at this point be wondering, why am I talking about this and what does it have to do with security? 2 reasons. First is that the way we as engineers or developers deal with cost is the same way we think about security. It is simply not an integral part of our project's lifecycle, but more often than not, it is basically an afterthought. The second reason is that once you start thinking in terms of business and cost and expenses, security starts to climb more and more and more on your priority list, right? And if you know how to explain it to management, you will get their buy-in to deal with that, and you will get their buy-in for all the future things you want to do, because suddenly they will understand that you're bringing actual value that they understand to the table and that you care about the bottom line, right? As we all know, security is not a simple subject, and it's quite wide. For the intents and purposes of this talk, I'm going to focus on one segment of it, and it is simplest to fix, and it can be a project or a company killer when mishandled. So let's start with some data points. On average, 1,800 unique keys daily are being leaked to repositories, to public repositories, right? As a developer, this might not be of too much interest to you. On the other hand, as a business person, this is a hair-raising experience, because we are starting to think in terms of damage to the business, potential losses, costs, both direct and indirect. Let's put it another way. In the first 6 months of this year, 4.1 billion records have been exposed in data breaches. That is a lot. That is too much. So what are the common ways of revealing our secrets and credentials? Well, either you make them public, right, by committing them to repository and then making that repository public, or a malicious third party gains access to your infrastructure, for example, server, right? First case is most clear, but let's talk about the second one for a moment. Someone gains access to your server, and it can be done regardless of your setup, which I hope you have. If you're running Docker or Kubernetes, I'm going to assume that your container setup does not run under root and that you are running the latest versions that has the most recent CVEs patched, right? If you have an ops team or infra team, hopefully they have monitoring in place. If you are a smaller outfit and you don't have that, hopefully you have something like this implemented. This is basically a tripwire system that is going to send you an email whenever an SSH connection has been established. With that in place, you can actually take steps to prevent bad actor and, for example, start a server. So you get an email, you ask the persons or whoever is allowed to have access to the server, which I hope is very low number. If they are doing something awesome, if they are not, you can take steps, shut down the server, and go away. On the flip side of this, the person who is accessing your server without permission operates under the assumption that there is some kind of tripwire in place, and then when they log in, the countdown timer begins, right? So they're trying to race against time to get as much data as they can, and then go to sift through it later. So if you have your secrets, credentials, whatever, in your config parameters files, or whatever you want to call it, you just handed the keys to the kingdom to them, right? Because you were nice and hospitable. You are about to experience a lot of things, and some of them are quite unpleasant. From incurring cost for a security incident review by external consultants, to losing your customer trust, to losing potential customers, to losing potential sales due to your downtime. And your code and architecture will basically do nothing to save you from this. On the other hand, your attitude towards business and security might, right? So if you're still not with me on clear text as credentials, let me tell you a story. So there was a person who basically built a hobby project, and he was running it on AWS. And he decided that he wants to do the simplest possible thing that he could do, which meant he was using AWS unscoped IAM keys, right? And he was using them to connect to his account and do stuff with it. He committed them to the repo. I mean, what's the problem? No biggie. What could possibly go wrong? And some time passed, and he basically forgot that that was in the repository. Then he made the repository public by accident for a whole 15 minutes, not more. In those 15 minutes, somebody has scanned the repository, he got the keys, and moved along. At the end of the month, that person received a $15,000 bill. That's a lot of money. And just because he was not careful. Yeah, these days, GitHub and other code repositories do scan your commits for a potential IAM keys, and then send you the notification. But back then, it was a completely different story. So yeah, you are not using your config.ini, you are now using environment variables, right? It's awesome. So you have a .env file, and you set everything you need in that. And you have a local dev file that has one set of credentials. You have possibly another .env file that is on the server, just that is being maintained just by responsible people, and you're all good. And of course, there is a chance to commit actually to the repository, but you're avoiding that, doing your best, but you're kind of forgetting a few things, like this. This is a Google search for .env, and this is devastating. So again, even if you have your .env file unindexed and used properly, a skilled person, once he has access to your box, can actually collect them quite easily. This is one way, right? And then we are again back in the problem situation. So, on the other hand, you're using containers. Awesome, right? So you're passing environment variables in the container. So you're passing them to the Docker engine, which then I could use this command to list all the environment variables for that. And if you're using Docker Compose, let's talk about what happens when that beast starts to grow. So every time you introduce a new item, you need to add to Docker Compose, and then you need to push it around and have everybody update their credentials and share them. And how are you actually sharing them between your team? Are you using email or chat client? Is it actually secure? Do you even care, right? And then you tell me, hey, but we're going to use Docker secrets, and I'm sorry, but I'm going to start laughing. Because you're telling me that you're going to use a file-based clear text location, clear text file that is located in run secrets and then the name of the variable. Please tell me more about security, right? Even if you squint and pretend that this is not an issue, you should keep in mind that official images might contain vulnerabilities, right? Because I'm sure that each and every one of you actually inspects the containers they're using, right? You're just not collecting them all like Pokemon, yeah? Sure. But if you're working on a project that has dedicated infra or ops teams and they let these problems in production, and I know some of them, they do, you really need to have a long discussion with them and with business present about how they should get their act together and why their actions and decisions are ruining the business and why they need to improve. Some of you may have an idea where I'm going with this, so let's clear this up. Up to this point, I have been using some concepts, but I still haven't used their names, so here they are. Liability and criminal negligence, right? If you want to learn about them quickly, here's an idea. So you ask your boss to have a meeting with company counsel present, right? And you want to discuss what happens in case of a data breach and subsequent litigation when people actually start suing you because their data is out there in the public, right? So you talk about it and you say, hey, they say, but yeah, but reasonable security measures have been taken, right? And you say, sure. And they ask you what it means, and you say, hey, we are putting our secrets and credentials in a file, clear text. And they ask you what it means. And you tell them this means that anybody who has that file can actually open it and read it. Then sit back, relax, and watch them as they process the information. And watch as their reaction changes when they understand how big of a problem this is. You're probably going to be introduced then to a nice term called criminal negligence. Now, Somebody's going to say, but hey, we have insurance, right? And we are covered for this, and this is really a non-issue. That's really a dubious question, because you might have insurance from damages by third persons, which is like the regular kind of insurance that the company have. You might have insurance against cyber attack, but it doesn't mean that it actually covers the data breach scenarios. On the other hand, if it hits the fan, or you have to decide premiums and you have to go through the motions and tell your adjusters, like, what are your reasonable security practices, I mean, good luck, you're going to have to explain that you're still storing your stuff in clear text. You got it, you'll prevail, right? Another situation that we have is certification, and specifically ISO 27000. Hopefully, you will get to work on a project where this kind of certification becomes a requirement. And for example, when one of the bigger sales by larger companies hinges on the fact that you have ISO 27000 certification, you will find out pretty quickly that things get expensive and costly, because security and secrets management and stuff like that was just not high on your priority list because you had other things to do. This is why I'm talking about cost and security together, because more often than not, they are the same facet of business, right? We are talking about the cost and the damage control and maximizing profits by not losing sales and decreasing the liability potential. And this is something that is really important, right? So how can we actually improve this, right? The answer is to use secret management applications, right? So what kind of features do those systems need to have? First and foremost, you need to have ease of setup and operation. You want to have a setup that you can configure for new secrets relatively easy. You want the configuration of the set system to be relatively straightforward and not to be ambiguous. You also want to have a clear path when you need to upgrade it to high availability solution or multi-data center. And the way your application should interact with those systems should be as straightforward as possible. It is always a good idea to have an expiring secret, right? Because your application should really not care about this when it emits the request. Fresh data needs to come in. On the other hand, the ease of the changes of the secrets for the admins means really a lot, because then they have shorter time for a turnaround, right? And you want that to be as effective and as efficient as cost-effective as possible. And then we come to my favorite. At first, talking about dynamic secrets, really, it's not that big of a deal. But when you start thinking about dynamic secrets in terms of business, it opens a lot of options. Meaning that if you squint real hard, all of your configuration is actually a secret. And that means you can store it in a system, right? But depending on the token that has been emitted, a different value can come in, because you can interpolate them. So that means that you can have different values for production, for staging, and then you think about a local development environment where you need to keep all your developers in sync, and suddenly that problem that I mentioned, the downtime of just sitting down and waiting for somebody to pass you the information, goes away, right? So we have this encryption and transport at rest. I don't think we need to spend a lot of time on this. This should be a given and should be understood. And of course, you have choices of backends, because you can either use local secure and encrypted storage, or you can use an RDBMS, or you can use AWS or any other cloud provider or whatever, because these things can then be tailored to more easily suit your need, right? And of course, let's be honest here, we all like costs to be close to zero. This is, of course, sometimes impossible, but we can do a lot to keep them down, right? By having a straightforward installation and configuration, your team will spend less billable hours on those problems. By having something like dynamic secrets, can you make your setup simpler, and you will have a more productive team where the downtime due to configuration becomes a thing of the past. There is quite a lot of tools out there, and they are not new. So this is 2019, the first I think appeared around 2014 or somewhere around the vicinity. So that means that they have been there for a long time. They have matured. Some of them are quite good. Some of them are weird, right? And if I can, I like to use tools that are open source tools that are backed by a company wherever I can, right? So briefly, I'm going to touch on two of them. We cannot escape AWS and Amazon, like even if you wanted to. They have a couple of products that deal in this space, but one of them is Secrets Manager. It is basically their native way of storing secure key value pairs. It has some rotational capability, but outside of RDS, you actually have to write all those functions on your own. Also, secrets management is single region only. If region lock is not a problem, there is a bigger potential issue, and that is the price. And it can widely differ depending on your usage. Let's take a look briefly at two examples. So this is example one for a production scale web application. So you have two servers and two SSH keys and two API calls per SSH server, yada, yada, yada. When the calculation comes in, it's $6 a month. Not bad, right? It costs less than your engineering team, a minute probably of their time. But then you have something like microservices when you have these 5 million secrets which are valid for an hour and then you rotate them, that's 2 API calls, yada, yada, yada. $3,000 a month. That's a lot. That's a lot of a difference, right? So the other tool that you will probably hear about when you start talking about infrastructure and secret storage is going to be HashiCorp Vault, right? So why is it a good fit? Because it has a small binary to install, the configuration is relatively straightforward, and with the use of SSL certificates, you have a nice secured HTTP transport for your secrets. This can be done basically by a single developer or non-dedicated infra person. On top of that, you have high availability mode if you need to scale, and depending on your needs, you can have the choice of multiple backends, right? And on top of that, it uses something called, I apologize if I butcher this, Shamir's secret sharing algorithm, right? It is a way to secure a secret in a distributed way, which means you have one big string that is being split into how many pieces you want, and they are called shares. And then you define the minimal number of shares that have to be entered into the system for the system to get unlocked, right? Which means that once the system is unlocked, then Vault can actually retrieve the decrypted data of the storage backend and put it in an unsealed state. Once it is unsealed, then it loads all the audit devices, auth methods, secret engines, whatever. So now you are in a place where a client can actually connect to it. The client basically sends a HTTP request to authenticate, right? The first request gets validated if it should be allowed. If it is, then it goes through a whole set of policies to determine if the request actually has the rights to access the data that's sent. In the meantime, the client is going to get a token, which is basically like a cookie, which you're going to use to talk to your server, to your Vault, in future. And that's basically it, right? From then and there, it's just back and forth. If the cookie has a limited lifetime, which you can define, then you just need to emit the original token again. You will get back a new one and move along, right? What is important to say here is that policies are basically ACL rules, which you know, which means that you can fine-grain them, and any user can have multiple number of policies assigned to them. And if the action is allowed in any of those policies, user will have access to that data. On the other hand, if the user actually requires data that he doesn't have policy for, it will be bounced. You don't get a bulk sending and receiving, which is something that most people don't understand at first time. And all of this is being done with HTTP requests. This is basically all you have to do in PHP to get your secret badge. So you are emitting a HTTP guzzle request where you have the XVault token, which is the access token. You get back a a value, you just decode it, and you output or use what you need, and that's basically it. So if everything is that good, are there really no downsides? There are a couple of them. First and foremost, from my perspective and from the business perspective, is sealing and unsealing. So what that means is that if by any chance, for any reason, your vault gets restarted, your vault storage is going to be locked. Now you need to figure out the way, how are you going to unlock that quickly, because sometimes it is in the dead of the night, sometimes people are at vacation, and you need to figure that out. The other thing is basically HTTP calls, right? This might be a downside, but I'm certain that in 90% of the cases it's not going to be a problem. But if your network stack is actually overtaxed, you might encounter latency. On the other hand, like if you really want to press an issue and you have to weigh between possible latency and having a peace of mind, knowing that your data is kind of secure and you have less of a problems, I mean, it's not even an issue. But if you really want an answer to HTTP calls problem, it means that you need to implement HTTP2, and then all this goes away. So let's recap how this all fits together, right? Vault token goes into the config file. Hooray, right? Then token gets sent to the Vault server. The client token is returned. Once only retrieval of the secrets that have been granted to the ACL is possible, and when lease of the token client expires, Vault token is used to obtain a new one. It's very simplified, but basically that is it, and that is how it works. In case of a breach, so your tripwire hopefully gets triggered. Your files are going to be downloaded, possibly the configuration files where the token is stored, or maybe they will actually get the Vault storage, but then it's going to be locked and it's highly encrypted, so it's going to take them a long time to actually be decrypted. You then remove your server from the public. You rotate the token. You rotate the tokens that are being used. You update the configuration, and you make the server publicly available and move along, because now you don't have a problem anymore. So for the final words, even with these potential drawbacks, using Vault or similar system pays off a lot, as your company and or product will be protected from unwanted liabilities, and in the case of actual unauthorized server access, your configurations will be stored securely. Because according to the IBM's security research, the average cost of a large data breach, which means more than 1 million records lost, in 2018 was $3.9 million, right? This figure takes into account many categories of the expenses that are basically rising from the breach. That means includes loss of business, technical investigations, legal penalties, employee time spent on recovery, and everything else possible. And with this in mind, I believe it is significantly cheaper to invest engineering time to solve this low-hanging fruit rather to let it run its deadly course. The end. Thank you.